are scope for further improvements and various automations in the plant and the manufacturing area as well. And one of the critical components is on the warehouse side, where warehouse is a place I think most of us would have known the material will be kept or stored, and then it will be retrieved accordingly based upon the request and for the usage purposes. So automation on this warehouse is again one of the very key and critical important thing, because the complete supply of the materials inside the shop floor depends on this warehouse management and also the inventory management, which will help us in calculating the inventory which is required for the upcoming production, and also for delivering the correct product at the right time to the right place is something very crucial and critical as well. So in that aspect, the storage automation, which will help us to reduce most of the manual works currently done manually in the warehouse area, and how these complete process can be automated, and how this can be integrated with other systems seamlessly as well, so that the material movement or the material request for a particular set of operations can be given to the right people at the right place at the right time. So with this concept or with this introduction, we'll go into this today's session on storage automation, where primarily I will just to focus on this warehouse 4.0. So in continuation or in um, uh, what in additional to the industry 4.0 technologies which we are currently seeing, and there are many improvements or many digitization process coming live, like lean 4.0, quality 4.0. Similarly, this warehouse 4.0 is one of very crucial and critical place where lot of materials has been handled manually, and the people effort has been considerably put in this particular area to keep track of the materials, and also to keep track of the inventory, and also to manage the materials inside the warehouse. So how this complete process can be automated? There are multiple technologies like barcodes, RFID scanners and readers which has come into existence. So with help of that one, we can easily track the components, but inside the shop floor where this components is been going on, and what is the inventory required for the next set of production, and how to completely store and automate the complete process is something that this warehouse management system is also currently focusing on, or warehouse 4.0 is currently focusing on. So if you can see, majorly the product material supplies will be stored in the warehouse. So the materials will be given to the manufacturing, and once the material has been finished or converted to finished goods, that also will be stored in the warehouse, that will be given to the customers. So it is like kind of an start and end the complete process, and intermediate there are many intermediate warehouses or intermediate storage places where the materials will be kept for the further set of processes. So the storage and retrieval of this particular material set through the complete manufacturing life cycle is very crucial. So only this warehouse 4.0 concept also came into existence, and there are multiple technologies that came to support this warehouse 4.0 concept. And one of the primary technologies is the automatic storage and retrieval that we are going to see in the next slides. So what are the key elements of in warehouse 4.0? Something like receiving the materials. So once we have the master planning schedules according to the manufacturer need which they have currently planned for, then we have to get the required materials from the vendors, and it has to be stocked in the warehouses according to the schedule. The material and has to be dispatched to the particular machines or assembly lines. So this is one of the key elements in the warehousing, receiving the materials and then stocking the materials accordingly, and storaging the material so that it can be easily identified. That is one of the key elements as well. The material should be easily able, we can the operators or the personnel should be easily able to identify the material and retrieve the material within a very short span of time. If the warehouse or if the manufacturing is a huge plant consisting of 100 to 150 machines, then the warehouse will be also very huge. So the material location and storage is also very crucial and important point. And picking up of the materials where the material will be picked up, and also once the material is being done or material is manufactured or converted to a usable product, how that product is again stored in the warehouse in forms of an easily identifiable method. So that also is a critical point, and then from there it will be shipped to the next stages like customers or end users, whoever it is. So these are some of the key elements comprising in the warehouse 4.0, and particularly we will be seeing upon the storage and retrieval part here. So storage and retrieval system is something is very now becoming very common for very large manufacturing industries, where the materials will be stored automatically and it will be retrieved automatically in terms of multiple racks based system or pallet based system or a bin based system. So whichever is convenient for them, the materials will be stored accordingly and it will be retrieved accordingly. So the automated storage and retrieval system is nothing but a computer and the robot-aided systems that can retrieve the items and store them in a specific locations. So whenever we want to again get back to a particular material, we can easily access to that material and that will be retrieved automatically and it will be given to the particular person who is requesting for a particular material. So this is the key concept of automated storage and retrieval. And again, it comprises of multiple elements there, where it has a huge a kind of a crane kind of a structure or a conveyor kind of a structure, and the robots will be implemented in order to automatically pick and place. So there are multiple elements which will comprise this complete storage and retrieval system, and that can be converted to automatic storage and retrieval system. So here we would just see what are the key components of this automated storage and retrieval system. The first and the major foremost component is the storage racks or the storage structure, like how we want to store the components. Like ASR systems, as the figure also indicates, it contains several rows of the storage racks for sorting the material items, so that it can easily be identified on which row or which cell it is being placed, so that it can be easily be retrieved. And all this data will be connected to a central computer or a central platform in the form of application, so that the users can just access the complete materials or the storage system with the help of the application platform as well. So one of the primary and foremost components is the storage racks or storage structure, how you want to place it, and then the transport devices. Um, the transport devices which will help us to access the particular materials inside that structure, and then it can able to lift the material and can able to deliver the material. It can be in the form of autonomous mobile robots or automatic guided vehicles or conveyors or any kind of material movement, automated material movement, which will help us to bring the material to the required station. So as you can see, the incoming materials, it will be sorted out in the form of it will be sorted in a particular order and it will be stored in a particular order. Then once the pallets are loaded, pallets or bins or whatever the storage mechanism we are going on, the sizing stations, it will be passed to the weighing and sizing stations, so that it can be loaded and it can be stored in that particular locations. So different size materials and different weight materials will be stored accordingly, so that the higher weight components will be stored below and lesser weight components will be stored above in the rack, so it can be easily accessed. So these are some of the systems which will help us to easily access the material. That's the second critical component. The third one is the pickup and delivery, PND. We call it as PND station. That is nothing but the input and the output stations. So where the user will give the input of what the material is being requested, and the output station is the required material will be delivered to that particular user. So that is the pickup and delivery stations in this complete ASRS system. And the fourth critical component is the storage and retrieval machine. We call it as the cranes or any other mechanism which will move inside the ASRS system. So whenever there's a request from the application or the platform side, this automatic movement of this particular retrieval system will be initiated, so that it will go to this particular rack or particular cell, and then it will get the required material and it will place on a particular AMR, so that that can, or the conveyor, so that it will be
Giving a max point.
sorry. Hello. So this is the fourth critical component in the ASRS system. The next one will be the, as I said, central computer control system, where our application or the software will be running in order to complete the container operation of the storage and retrieval system. So the sorting of the particular material, retrieving of the particular material, the command to this particular AMRs or the cranes to retrieve the particular material, everything will be, and also which location is free and which location is full, so that the material can be loaded, or whether the complete automation, whether the complete storage system is full or half empty or full empty. So all kind of required insights can be got from this particular central application, and it can be planned accordingly for the next set of storage systems. So these are some of the very, very crucial and critical components for the automated storage and retrieval system. So once we select, okay, the critical components, next is like what type of automated retrieval system will be suiting for us. So there are multiple types of ASRS systems. We call it as ASRS in short form. Automated storage and automated retrieval system is something we call it as ASRS. So there are multiple types. One of which is first one is the unit load ASRS. But unit load ASRS is pretty much bigger in size and is used for heavy load components or heavy load parts, which will be ranging from 1,000 to maybe 5,000 or 6,000 pounds. So those kind of heavy, huge particles, components can be stored there. And then it will be constructed in the form of a narrow aisles. There will be multiple aisles. It will be there, and there will be multiple rows in between between the aisles, so that the components can be stored there, and the height can be vary from anywhere from 50 to 100 feet, so that we can store multiple materials there. So this is one kind of an storage system where it is used for heavy components. The next one is the fixed aisle unit load, where it will be used for little bit lesser weight loading systems, loading components, where as the name indicates, there will be a fixed, the crane or the movement will be fixed to one single aisle, and then that will be keep on moving to retrieve the material for that particular location. The third type is the movable aisle unit loader. As the name indicates, the difference between the fixed aisle and movable is the fixed aisle will have a fixed crane for a particular aisle, and this one will be movable crane too, which can be servicing or which can be configured with the multiple aisles. So that's one of the key difference between these two. And mini load ASR systems are there, which typically hands for smaller loads up to 75 pounds. So instead of full pallets or bins, it will be the materials will be stored and retrieved in the form of trays or carton boxes or something like that, so that it can be easily handled for pretty much smaller materials. And next type will be the shuttle-based ASR systems, where a bot or a Kobo, sorry, in a, automated bot will be shuttling between the ASRS racks in between, so that it can able to fetch the particular material, go to the different levels, any heights it can reach, and it can bring down the material within a quicker time. So that is the shuttle-based ASR systems, and AMR-based high-density ASR systems also available, where multiple AMRs will be used in order to reach a particular material, and then it will be bringing on that particular material based upon the request. So this is one kind of an system for ASRS. And the carousel-based ASRS is something like as a kind of a circular inventory, or in a kind of circular path, it will be keep on rotating along a conveyor to retrieve a particular material and store a particular material. So this is one type, and this is more commonly used ASRS system is the vertical lift module, where it will be having an complete vertical aisle setup, and there will be multiple inserter and extractors in the center of this particular VLM module in order to store and retrieve the materials. So whenever the item is requested from the central communication system, this inserter locates the necessary tray or the bin or a pallet, and it will retrieve and delivers to the operator. So this is something most commonly used ASR systems in the manufacturing industries. So in this slide, it will this video, quick video, it will show how maybe some kind of different different types of ASR system. This is unit load ASR systems of this configured, and this is kind of a mini load ASR systems that can able to have it. And this is the vertical lift module where it will can able to store the materials and retrieve the materials from there. And this is shuttle based ASRS, as we seen, right? It will be shuttling between the systems and it will deliver the material accordingly. And this is the horizontal carousel. As we've seen, it will be keep on rotating, and the materials will be stored in the form of, it is a fixed storage system there. And this is vertical. Similarly, it is a vertical carousel. And this is cube-based storage is also one form where there will be multiple cubes allocated, and automated robots or cobots will be used to pick up and place the materials at the required station and deliver to the particular station. So these are some kind of types of automated storage and retrieval systems currently available in the market. So how this complete warehouse automation in terms of digital process automation, physical process automation to converge together to have the complete warehouse automation. So digital process automation right from our IT, information technologies, all our infrastructure, all the required software application, cloud database, machine learning algorithms, everything will be converging there. Similarly, physical process automation, where most of our OT parts like robotics, GTP systems, ASRS, and AGV, AMRs will be combined together. So all this combined together will give the complete warehouse automation system, so that the which will enable the easy access and retrieval of the materials from the warehouse. And this is a typical architecture for one warehouse model, or ASR system will be looking like. So where the material inward will be there. So once the material is coming, it will be converted, or it will be inverted into the ERP system. So once the ERP system is there, then it will be going into the RS production central server system. So from there, we will be having multiple elements to access, like storage rack, conveyor system, and the storage retrieval equipment to give the commands, and also control system to control the storage retrieval equipment. So all these commands will be coming from the central storage retrieval system, and then that can be again integrated with our production system, so that the request will be coming from the SAP or ERP from the production shop floor, that will be communicating again with the central server. Also the materials will be automatically taken, and it will be given to the required stations or required assembly lines. So what are the key application of automated storage and retrieval system are typically used in applications where there are very high volumes of loads which is required to be moved inside and outside of the storage. And storage density is very, very important because of the space constraints. If there are huge space constraints, then we can keep on going in the rack-based system, so that we can keep on piling up the required materials there. And there is no values added in the process, and only storing and retrieval is there. We will be directly going for this automated storing and retrieval process. And if there is any, considering the safety considerations of the operators also who is handling heavy equipment or heavy loads, so in those kind of areas, we can go for this automated storage and retrieval system. And this is one kind of use cases that is implemented in an hydraulic company, where the customer was using around 1 or 2 square meters for storing the bins and cartons, which includes very smaller line items. So the biggest challenge was to manage inventory for small items, and also picking time and the delivering time was very, very higher. So then they went for this automated storage and retrieval system, where the footprint is reduced to almost 20%. That is, the area covered by this storage system is only 20% compared to the manual spaces. So 80% of space which was earlier used for stores is now used as an R&D center there. So warehouses shifted outside the plant, and also multiple warehouse management system has come into picture, so that the materials can easily be managed there. So the major benefits that I realized: faster product delivery, improved stock control, minimize pick and place errors, efficient order picking, and shorter lead time. So these are some of the very critical benefits that has been realized from this automated storage and retrieval system. And these are some of the factors that will influence the cost of selecting the ASRS system. So the cost of the ASRS equipment completely, what kind of ASRS system we'll be going for, and overall size and weight of the product that has to be handled. This has to be based on that, the ASRS system can be selected, and what kind of storage space we are looking for, the operating environment, and any special material handling requirements are there. So that has to be handled separately. And what is the required throughput time? Some machines needs to be given the very high frequency material has to be supplied to that particular line. In some stations, the material needs not to be supplied at a regular interval, because the machining time and cycle time will be more. So based on that particular we can select our ASRS systems, and also integration with existing process and cost of customizing. So these are some of the critical factors that will influence the cost for an ASRS system. And these are some of the major benefits of ASRS system, as we've seen before, like efficient usage of the floor space is highly possible by the ASRS systems. And then we can keep on racking these things, so that will give us more space there, and labor cost will be reduced, safety will be increased, and then the picking up order and delivery accuracy is much increased. So these are some of the major benefits that we are looking that we're getting for the ASRS system. So now I would just quickly show you a demo video of one of the ASRS system being implemented by our partners Craftsman Automation here. So this will quickly show you how the ASRS system is working. So this is how the storage system will be kept there, and this is the cranes, as I said, that will be helping us to retrieve the material. So 60, this is pallet-based material retrieval system where the materials are racked on this pallet, and this pallet will be removed and it will be delivered. So this is kind of an application where it can be integrated with the ERP, existing ERPs as well, and the conveyor system is also there to easily transport the materials. This is used to lift the material and store the material there. The weight will be checked automatically, safety, the size will be checked automatically, and based on that, the material will be placed. All the required safety parameters like overload or oversizing or any manual intervention, everything is implemented here. And it has the emergency stop button is provided in order to quickly stop the in between operations also. So these are some of the examples of stacker cranes as well. The different types of stacker cranes available also. So we'll quickly show another video demo of this V-Store we call it as. Where again this is kind of a vertical storage system. The components are racked vertically, and then it can be retrieved easily also. This is a very commonly used storage system. So all our smaller parts and components can easily be stored and retrieved automatically. So it can go up to minimum of maximum of up to 100 to 120 feet height. The materials can be stored and then it can be retrieved from there. This application which is used to control this the complete system as well. So where we can able to select the required material and the system will automatically give it. The required reports also can be got it from there. That who has required what material, what time. So those kind of insights also can be got from this particular system.